Alright, so today we're starting Unit 2, or Chapter 2, which is all about polynomials. So if you're tired of dealing with functions, polynomials are still a type of function, but we're getting away from like function notation and all the function things we've been doing. We're now going to look at polynomials. We will be doing a lab on Wednesday and Thursday. So basically that will be like instead of a concept check this week. So like it'll be 100 points, but it'll still be in the formative category since it's only going to be 2 days instead of like 4 or 5 days like we have done with some of our projects. Okay. We will have partners on that, but it's pretty fun. So we're roller coasters. But in order to get us there, we have to figure out what a polynomial is first. What is a polynomial? Have you ever done polynomials? Let's break it down. What does the prefix poly mean? Many or a lot, right? More than one. Okay. And what does nomial look similar to? Looks similar to kind of like number, right? Which for us, number means both a number, but it also means like x's. So like basically our nomial means terms. Okay, because we've talked about monomials means that I have one term. Binomials is 2 terms. Trinomials is 3 terms. Anything after that, like we don't have special names for them. They're all just polynomials after that, which is what we're going to be looking at today. You don't have to write this down, but just so you know, this is the like super mathy definition of what a polynomial is. Basically, when we're looking at it, notice that our n's, okay, so we have n minus 1, n minus 2, those are all the exponents. Those all have to be positive, so we can't have negative exponents, and integers, meaning whole numbers. So like we're not going to have fractions in our exponents. And then also, all of the a's, so the a's in the front are going to be our coefficients. So all of those have to be real numbers. So we're not going to be dealing with imaginary coefficients. And then we start in standard form, so that's what this is called. I start at the biggest exponent and work my way down all the way until the constant, which is a sub 0. Yes. Hopefully that looks vaguely familiar. What would our leading term be? The one in the front, right? So I have a to the n times x to the n. Okay. Which is helpful because if I write it in this descending order, okay, that also means that my degree is going to be my biggest exponent, and your leading coefficient is just whatever that number is. Yes?
And what's the name?
N. So like whatever that first exponent is. So it's just the biggest exponent. And we're going to look at an example here in a second, where we don't have a bunch of variables with it. So speaking of examples, we also have what's called even and odd functions. So these are also going to be important. We're going to label things as even and odd. The 2 biggest takeaways from even and odd functions, okay? So for an even function, it's going to meet the requirement that f of negative x has to equal f of x. Which means that, like here, if I plug in, say, -2, we got out -3. Which means that also if I plug in +2, I also have to get out -3. Or like if we plug in -3, I got out 2. So that means when I plug in a +3, I must also get out 2. So it's going to be like symmetric over your y-axis, or like horizontally. It's kind of like mirrored, okay, horizontally. The other big thing, since we're dealing with polynomials, is if our degree, or the highest exponent, is even, then your function will also be even. Kind of makes sense, right? If your degree is odd, then your function will also be odd. And it is symmetric about the origin, which is a little bit different. So like if I have g of negative x, so let's say I went to -1, we got positive 1.5. Now when I look at the positive part, so positive 1, I'm going to get the opposite of that. So I get negative 1.5. We're looking at -2, we get positive 2, which means that when I plug in positive 2, I get -2, and so forth. So it's going to have the opposite y value now instead. Okay. But biggest thing to notice, what do we notice about our ends of our first function? Of the graph. They do keep going forever, okay? Which is important because we're going to talk about this idea of end behavior. So, what is the notation that we use in math to say go on forever? Infinity. So, we're going to be using some infinities and negative infinities to mean to go on forever. Okay? Do we notice anything else about our ends on our first one?
They both go up.
No, is that the same for my second one? No, okay. Can we think of another even function? What's another really easy even function? Yeah, x squared, right? So what does our x squared graph look like? It's a parabola or a U shape, right? Do both of my ends go up for that one? Yeah. Okay, what's another really easy odd graph? Yeah, just x, right? Do our ends go opposite directions on that one too? Yeah. So in general, our even functions are going to have the same ends, and our odd functions, anything odd means opposite, are going to have opposite ends of the graph. That is important, so you might want to write that down somewhere if you don't already know that. Now, I did say we're going to use a notation in here that deals with infinities to talk about our end behavior. And that is getting us ready for calculus. Okay? But we're going to use our leading coefficients and our degrees in order to help us figure out what our ends do. Because like we just said, if my degree was even or odd, that's going to help us to decide if both my ends go up, down, or if they're opposite. So what's my leading coefficient of this first one? 3. What's our degree?
X. Wait. 4.
Just 4. Okay. What's my leading coefficient of the next one?
12.
Not quite.
12 X. Here's 7.
Why is it -7?
Because it's attached to the highest exponent.
Yeah, so technically we would want to rewrite this so that our biggest degree comes first. And so it is 4. Which means that our degree is what? 3. Okay? What's our leading coefficient of our last one? Just 4. What's our degree?
1.
Do be careful. Because the 1 would have to have an x there, and I don't have an x. It's 0. So for a constant, your degree is just 0. Now here's a question. Is 0 an even or an odd number? Is 0 even or odd? It's not neither, just so you know.
It's even. Is it like a neutral?
It's not neither. Now 0 is neither positive nor negative, that is true. But it is even or odd. I heard a couple people say even. Why do we say even?
Because it's like 0, 1, 2, and 0. It's like every other number is even.
Okay, I'm with you. So like when we think of even numbers, we think of like counting by twos, yes, or that like 2 can go into it, right? So you were like skip counting 0, 2, 4, so forth. Agreed? Or like if we think of it like I can divide by 2 and have no remainder, yes? Like 4 divided by 2 is 2, I don't have a remainder. 5 divided by 2 is 2, but I have a remainder of 1, yes? 0 divided by 2 is 0. Do I have a remainder? No. So 0 is an even number. So that means that all of our constants are even functions. Does that kind of make sense? A little bit of thinking for us on the Monday. Alright. Now let's look at, this is that limit notation or like the infinity notation that I was talking about. So let's first break down. We said that my ints go on forever, and we represent forever with infinities in math. So over on the left-hand side of my graph, okay, I'm going to use this arrow, right? As we go more and more left, what's happening to our x values?
Are they like decompressing?
Not. So like what type of numbers do we have along our x-axis as I go
Oh,
left?
you're going right. Is it negative?
Yeah, they're negative,
Yeah.
right? And we're getting more and more negative, yes? The farther we go left, the more negative we're going to get. Agreed?
Yeah.
So you're going to be getting like bigger and bigger numbers, but they're going to be bigger and bigger like negative numbers. So we would say for the left side of our graph, our x is going towards negative infinity. We're okay with that.
Yeah.
On the opposite side, as we go to the right, what's happening to our x values there? They're positive and they're getting bigger and bigger and bigger and bigger. Yes? Okay. Which is why for your left in behavior, we talk about x is going towards, that's kind of what this little arrow means, is goes towards, right? A limit is just, you're looking at what y values, okay? What are your y values doing as x approaches this stuff, okay? So what's my f of x or my y values doing as x goes towards negative infinity? They don't use a plus sign here. I tend to use plus signs with my infinities because some of y'all are real bad at drawing infinities. And so it can be hard for me to tell, did you just draw a weird tail on there? Did you mean for this to be positive, right? Did I mean for it to be negative? So if you just always put a plus or minus in front, it gets much easier for me to tell which one you were actually trying to write there. Okay. But we also need to talk about then, so we're trying to describe what f of x is doing. So remember from our graphs that we looked at a second ago, okay? Our ends are either going to point up or they're going to point down forever. Yes? Okay, so if we point up, what type of y values are we getting there?
No.
Positive. If we point down, what type of y values are we getting there?
Negative.
Negative. Yes? So these are going to equal either positive or negative infinity. If it points up, it's going to equal positive infinity. If it points down, it's going to equal negative infinity. And you are going to be expected to use this notation on your test. So you might practice it on your homework, just if you're using the right notation. So speaking of, let's try and use the notation. So let's describe the end behavior in limit notation. So let's start with the left side over here. So we said if we're talking about the left side of our graph, that means that our x is going towards what? Negative infinity. Yes? And if we're pointing up, that means that our y values, or our f of x, is going towards positive infinity. So we would say that this equals positive infinity.
So because it's left, you put negative, and then because it's going up, you put positive.
Correct. So on the opposite side, right, if I am going to the right, that means that we're going towards positive infinity now. But we're pointing down, So now my x's are pointing
Negative.
negative, so we would equal negative infinity. I'll color code these in. Does that kind of make sense? Well, you try the next one on your own.
So we just like, do we just record like if it's going up or down, and that's what determines the number?
That it equals? Yes.
Okay.
So like the ones by the x determines, am I talking about the left or the
left
right?
or right.
The one here is
Is-
determining if I'm going up or if I'm going down. So what are our n's doing this time?
For the first one, it's going to be positive and
Mm-hmm. And for the second one?
be positive as well.
Because that's a positive thing. So what do we know about that function? Oh, it's going to be an even function, right? We don't necessarily know what the function is, but we do know it has to be even. Versus my first one would have had to be what? Odd. So we're okay with that. Which means that when I'm not even given a graph, I should be able to say what is going to happen to our n's just using our coefficients. So we are first going to find our coefficient, our leading coefficient. I'll specify that. Leading coefficient. And degree. So then remember that we are either even or odd, and our leading coefficient is either positive or negative. Yes? And we said that if it's even, then the n's have to do the same thing, yes?
Yep.
So if it's positive leading coefficient, that means that they both point up. If it's a negative leading coefficient, then they're both going to point down. Kind of like with our x squared graph, right? If I throw a negative on the front, it's going to reflect it, so they both point down. Now our odd graphs are opposite. I think sometimes it's helpful for us to like think about our x graph, right? Because my bottom, the left side is going down, and the right side is going up for your normal x graph, yes? For like your slope of 1. If we throw a negative on it, then they would flip so that the left side is up and the right side is down. That's the leading. So it's not a super like intensive test. Basically, it's just looking at your leading coefficient and the degree to decide what the two sides are doing. Okay. So look at one last example with those. So on this first one, what is our leading coefficient? -1. What's your degree? So if it's 3, that means it is a odd function, so they're going to be opposite. And since it's negative, that means that the left side is up and the right side is down. Okay, so how would I write this as a limit statement? The limit as
Negative thing.
of f of x is
Positive.
positive infinity. And then for my other one, it would be opposite. This one maybe?
Can you say what you look at to see if it's positive, infinity, or negative?
Sure. So on this next one, our leading coefficient is just what?
It's X. So,
Okay. Our degree is what?
4.
Okay. Which means that if we're even, what do our ends have to do? Be the same. And if it's positive, they're both going to point up. Okay? So remember that the positive and negative infinity with my x's is just talking about the left side and the right side. So I'm always going to have a limit for both of those. Because I'm always going to have a left and a right side of my graph. Does that make sense? Yeah. Now, what it equals depends on, am I pointing up or am I pointing down? So on this first one, this left side was pointing up. So it got a positive infinity.
Where do you see if it points up?
That was me using this.
Okay.
So if it's even and it's positive, both sides point up.
Okay.
If it's even and a negative leading coefficient, so I'll label this. This is leading coefficients. This is the degree. Does that help? Okay. So then if it was odd, which that's what that first one was, which means they have to be opposite, and we had a negative, so that's what told me the left side was up and the right side was down. Does that kind of make sense? Yeah. So we're combining our limit stuff that we just talked about a second ago with this coefficient test. Yes? Yeah. So for this one, since they're both pointing up, they would both be going towards positive infinity. Alright, I want y'all to try the last one on your own.
Degrees even or odd? That's makes sense. So this time they're going to be opposite again, but it's going to be flipped from our first one because our leading coefficient is positive. So this time as we go towards
negative infinity, we're pointing down. And as x goes towards positive infinity, we're pointing up. What questions do we have there?